Okay, this is the first of 3 videos to help you review for the final exam. We're going to go back to chapter 1 and 2 here. Let's see, what I would suggest you do is download the blank copies of these handouts and work on them yourself first before you watch this video. This is not all you need to know either. You should probably go over your WebAssign quizzes and tests as well as the class activities. That would be helpful. Anyway, these are just some of the greatest hits, and I'm going to go really quickly over here because we don't have a lot of time. Anyway, in chapter 1, we talked about difference between equations and expressions. This is a quadratic equation, right? When you multiply everything out, you got to throw it in the quadratic formula. I believe you get a 20 inside of there. So this is your answer, carefully. This one's tricky. You get rid of the negative exponents, you get your common denominator. When you factor the numerator, these are the same factor, but they're off by a factor of -1. So when you cancel them, you get a -1 left on top. This is important. Make sure you go over the absolute value inequalities. When you have an absolute value greater than or equal to a number, you got to break it into 2 cases. What's inside is either greater than or equal to 5 or less than or equal to -5. And so when you solve it, you get this, 8 to infinity and also -infinity, -2. This one, simplify this expression. Common denominator is going to be this times this. So this is what you end up with. Multiply this out carefully. Don't forget about the negative sign and the 5. You can cancel the x squares, and then when you factor out the h and cancel it, you get this. Solve for x. Let's see, solve this for x. You'd have to cross multiply. Multiply the left side out. I'm going to get the x's on one side, so I'm going to subtract x from both sides, add 3y, factor out the x and divide. So you should have gotten 3y plus 4 over y minus 1. Now this is a sneaky one. This has no solution because the absolute value of something can never be less than a negative number. Remember, the absolute value of something is always greater than or equal to 0. Graphically, if this were the absolute value of x plus 4, right? And this is the line y equals -2. When is this graph below this one? The answer is never. So that's another way to think of it. Let's keep going. All right. I like this one here. It says, find the distance between the x-intercept of this, which is a linear function. So the x-intercept, you let y be 0, and you get 4, 0. And the center of this. Now, this is the equation of a circle, so you have to complete the square. You're going to have to add 1 to both sides to complete the square on the x's, and add 9 on both sides to complete the y's. So you end up with, up down to this level, we don't really care about the 15. All we care about is the center. It's going to be 1, -3. So now that you've got those 2 points, now all you got to do is use the distance formula to find the distance that's between them. 4 minus 1 squared plus 0 plus 3 squared. Square rooted, and then it simplifies to 3 squared to 2. Yeah, some of these are kind of challenging. These are coming from section 1.9. Make sure you go over and look at some of the distance formula problems. Find the point on the x-axis that's equidistant from these 2 points. So what does that mean? That means whatever the distance is from here to here is equal to the distance from here to here. So if you just apply the distance formula, this distance, which would be x minus -2 squared plus 3 minus 0 squared, has to equal this distance. So anyway, set them equal to each other because it says they're equidistant. Square both sides, multiply it out. Notice how the x squares cancel, and when you solve for x, you get x equals 1/3. So the point is actually 1/3 0. This one, find the points on the y-axis. There's actually 2 that are 6 units away from this point. There's one up here and there's one down here. So again, just apply the distance formula. It would be 2 minus 0 squared plus y minus -3, which is y plus 3 squared, has to equal 6. Square both sides. Now what I did here, I got down to here and I did not multiply this out. Instead, I just took the square root of both sides. Square root of 32 is 16 times 2, right? So it becomes a 4. And when you solve for y, you get this. So there's actually 2 points. This one is kind of sneaky. Find the equation of the circle with center 2, -3, and tangent to the y-axis. If you draw the picture, you realize that r has to be 2. So that's all you have to do is use the definition of the equation of a circle, plug in 2 for r. All right, let's keep going here. Moving into chapter 2, you know there's going to be one on the difference quotient for sure. Make sure you practice that. This is f of x plus h, this is f of x, and this is h. The 2's cancel. If you look really carefully, the 2's cancel. If you don't notice that, the problem becomes messier. So you get down to here, get your common denominator of x times x plus h. And anyway, you can multiply the top out, cancel the x's. Now you can cancel the h's, and you get down to there. Okay, this one's kind of hard. I want to find the domain of this function. You'd say maybe this is coming from section 3.7, but I believe there's some problems similar to this in section 1.8 also. We actually skipped them in 1.8, but you should be able to do this on the final. Anyway, what's inside has to be greater than or equal to 0. So you make a sign chart. You look at where the bottom and top are 0, -2 and 5. And then you pick test points in between each region. Remember, I want this to be a positive expression. So either less than -2 or greater than 5. However, we don't include the 5. We do include the -2, but not the 5, because if you plug in 5, it makes the bottom 0. It's undefined. This one's kind of messy. I didn't intend it to be, but it is. Find the average rate of change for this function from x equal 2 to x equal 2 plus h. That's coming from section either 2.3 or 2.4, I believe, somewhere in there. It's f of 2 plus h minus f of 2 over 2 plus h minus 2. You get down to here, when you get the LCD, it's going to be this times this. However, so you're going to multiply top and bottom of the second one by 2 plus h cubed. When you multiply 2 plus h cubed out, there is a formula for it. It's going to be 2 cubed, which is 8, plus 3 times 2 squared, 3 times 4 times h. You get this expression. Plus 3 times 2 is 6h squared plus h cubed. It's kind of nice if you know that formula. So it's kind of a mess. You multiply it out carefully, and then you can cancel the 40s, and you can also cancel the h. This is a linear application problem coming from 2.5, I think. It might be helpful if it says linear. I would suggest strongly that you make a table. We talked about that. Make a table. And you have to compute the slope, and then you can use the y equals mx to get the y-intercept. And then the final answer is they want you to ask how many chairs can be produced for $2,000. You get slightly over 38, but the question is how many complete chairs, so you'd say 38 chairs. All right, we're almost done. A couple more things. Even and odd functions. An even function means the graph is symmetric with respect to the y-axis. Odd means it's symmetric with respect to the origin. This turns out to be an odd function. If you plug in -x for x, you end up getting this, which it's not equal to f of x, but it turns out it's -1 times f of x. That's the definition of an odd function. So if you were to graph this on your TI, you would see that it's symmetric with respect to the origin. All right, the good old composition of two functions, f of g of x, that's not too hard. This is something that students have trouble with, I know. Find the domain of this of f of g of x. The domain, x has to be in the domain of g of x, so x cannot equal -1, but that's not it. That's not all of it. You're plugging g of x into f, so g of x has to be in the domain of f, so g of x cannot equal 0. When is g of x equal 0? It's 0 when x is 2, so you got to rule out -1 and 2, so if you were to write it, so Webassign likes it, you'd have to write it like this. Finding inverse functions, well, the way you find the inverse function is you let y be g of x, you switch x and y, and then you solve for y. You get this. Now for these other two, this is something you should be able to do for sure. For this function, how do you find the inverse function? Well, let it be y. Now you switch x and y. Now to solve for y, you would divide by 2, and then you could either use the definition of logarithm or you could raise e to both sides, and you get this, and then you add 5. So this is the inverse function. G of x is e to the x over 2 plus 5. Last one, the way you find the inverse function, you call this y, you switch x and y, and you solve for y, just like we did up here. So you add 5, divide by 3, and the last step is you could either take the log of both sides, the natural log of both sides, or just say the definition of logarithm. They both do the same thing. So y equals the natural log of x plus 5 over 3, and that's your inverse function. By the way, if you wanted to check this, what you could do, remember, if you look at the composition of g of x with g inverse, you should get x. So I didn't do that, but g of x should equal x, and also g inverse of g of x should equal x. All right, folks, good luck, work hard, bye now.